Hello, mathematics lovers. I want to use a very simple example to introduce us to the concept of population mean and standard deviation. There's a simple question on the screen, as you can see. A physics class at a certain university has 200 students. The scores of 6 students were selected at random and are shown in the table below. Here are the scores. Now calculate the mean. A, calculate the mean, and B, calculate the standard deviation of the sample. It's very easy. Let's watch out. So for the A part, we're given the scores of 6 students, and the scores are 45, 66, 61, 72, 80, and 42. And then we're asked to calculate the mean, and here on the screen is the formula for calculating the mean, just the sum all over n, more like the average. Forget the big term mean they are using, is the average. So what we're going to do is to add all of these numbers divided by the total number. Our n here equals 1, 2, 3, 4, 5, 6. 6 samples were given to us, so our n is equal to 6. So the mean is denoted by x bar, and as we mentioned earlier, is just to sum all of these numbers and divide by the total number of the samples, which equals 6. So if you sum all of these numbers, what you would get would be 366 all over 6. And that gives us 61. So the x bar, which is the mean, equals 61. Very simple. So the second part of the question says we should calculate the sample standard deviation. Remember that in the class there are about 200 students studying physics. So out of these 200 students, a sample of just 6 was taken. So that will determine what type of deviation we are calculating. It is a sample standard deviation, not the deviation for the entire population. Now, what is the standard deviation? The standard deviation formula is used to find the deviation of the data value from the mean value. It is used to find the dispersion of all the values in a data set with respect to the mean value. Remember, we calculated our mean value to be 61. There are different standard deviation formulas to calculate the standard deviation of a random variable. Standard deviation is a measure used in descriptive statistics to understand how the data points in a set are spread out from the average mean. Again, remember that the mean is 61. So how are the different points, how did they deviate from this standard mean? That is just the concept that they are trying to, that standard deviation is trying to explain. All right, so like I mentioned, we have different formulas for calculating the standard deviation. If we were considering the entire population, we would have used this formula. But since we are considering just a sample from that population, this is the formula we are going to use. What is different? Not much difference. In this case of the sample, instead of us having just n at the numerator of this formula, we are having n minus 1. And that is very significant because we are calculating a sample. So in this formula, S is the standard deviation, n equals the number of the population. Our own number is 6, so n minus 1 is going to give us 5. X are the different values, while x bar is the mean. So let's watch how we're going to solve it. So this is the formula again. We have brought it out here. That the standard deviation equals xi minus x bar all over x squared. What you are expected to do is that you have to expand this formula to mean the square root of x1 minus x bar, you square it, plus x2 minus x bar, you square it on and on to xn minus x bar, and you square it again all over n minus 1. Alright, so that will give us, watch out, that's going to give us square root of our first number there is 45 minus 61, which is the mean. Alright, what we're supposed to do is to declare what we know already. So n is equals 6, x bar is equals 61. So the first one is 45 minus 61 all squared, plus the second number is 66 minus 61 all squared, plus 61 minus 61 all squared, plus 72 minus 61 all squared, plus 80 minus 61 all squared, and lastly plus 42 minus 61 all squared. Then everything divided by n minus 1, which equals 6 minus 1. So once we take the square root of that, we have gotten our standard deviation. Alright, so our standard deviation again is square root of 45 minus 61. So 45 minus 61 is that is minus 16 all squared, plus 66 minus 61, that is 5 squared, plus the next one is 11 squared, 0 squared, plus 11 squared, plus 19 squared, and the last one is also giving us 19, but that's negative, so minus 19 all squared all over n minus 1. 6 minus 1 is 5. So here's the tricky part, guys. If you're solving standard deviation, if you take the square of any negative number, you are going to get a positive number. You are never going to get negative. So take note of that, please. So here the standard deviation is going to give us square root of 256 plus 25 plus 0 plus 121. 11 squared is 121, plus 361 plus another 361 all over 5. The entire thing, the square root. So we're coming very close to the answer. On standard deviation, if you sum up all of this, simply gives you 1124 all over 5, square root of it, and that gives us square root of 224.8 rather, and that gives us about 14.99. So our standard deviation is approximately equals to 14.99, is the same thing as 15. Very simple. Sorry guys, my paper was out of scope. So here is the standard deviation. You work out these numbers, you get 256 plus 25 plus 0 plus 121, that's 11 squared, plus 19 squared, 361, plus another 19 squared but negative, but that also gives us 361 over 5. So our standard deviation equals, you add all of these numbers, you get 1124 over 5, and you work that out, you get square root of 224.8, which gives us 14.99. So our standard deviation approximately is 15. And that's all for this question. Standard deviation is very, very easy, but just know the tricky part and know how to navigate. For example, one of those tricky parts is knowing whether you are asked to find the mean of the entire population or a sample of the population, or and that's one of the tricky parts. Another tricky part is if you're squaring negative numbers, remember you are going to get positive numbers. So that's all about standard deviation. Please follow me for more. Like and comment on this video. Share this video. See you in my next video. Bye for now.